Hello and welcome back to Engineers Olympiad, where learning meets success. This video lecture is about the numerical portion of the chapter Introduction and Basic Concepts of Surveying. We have completed the theory part and you can watch those video lectures before watching this lecture, and those lectures are already up on the channel Engineers Olympiad. So let's begin. Question number 1. Question is, the area of a plan of an old survey plotted on a sheet is found to have shrunk so that a line originally 10 centimeters long now measures 9.7 centimeters only. Calculate the shrinkage factor. We have to calculate the shrinkage factor. Shrinkage factor is also known as shrinkage ratio. And why does this happen? Why do these plans or sheets shrunk? Due to variation in atmospheric temperature and humidity. Those discussions are already held in the theory part. You can watch those videos. So let's begin. So we have to find the shrinkage factor, which is also known as shrinkage ratio, right? And it's equal to shrunk length by original length. Right? So shrinkage factor will come out equal to shrinkage factor or shrinkage ratio. What is the shrunk length? So that a line originally 10 centimeter long now measures 9.7 centimeters only. So this is our shrunk length, 9.7 centimeters. And what is our original length? 10 centimeters. So shrinkage factor will come equivalent to 0.97. So shrinkage factor or shrinkage ratio is 0.97, and as I have already told you that it's always less than unity. It's always less than unity. This must be noted, that shrinkage factor or shrinkage ratio is always less than unity, right? So this was the question number 1. Let's move on to question number 2. Shrinkage factor or shrinkage ratio is always less than unity. And it's the ratio between shrunk length and original length. Question number 2. Question is, the scale of a map is represented by representative fraction of 1:4,000. The distance between 2 points A and B in the map is 10 centimeters. The distance AB on the ground is and we have to report the answer in kilometer units. Right? So the question is, the scale of a map is represented by representative fraction of 1:4,000. The distance between 2 points A and B in the map is 10 centimeters. The distance AB on the ground is, and we have to report the answer in kilometers, right? So as it's given, representative fraction, it is 1:4,000. That means representative fraction is 1 by 4000. What does that mean? That means scale is 1 centimeter is equal to 4000 centimeters, right? Every centimeter on a map represents 4000 centimeters on the ground, right? And the distance between 2 points A and B in the map is 10 centimeters. The distance AB on the ground is. What do we mean by scale? Scale is a ratio that every distance on the map bears to the corresponding distance on the ground. And here, as the representative fraction is given, which is 1 is to 4000, that means every 1 centimeter represents 4000 centimeters on the ground. Therefore, 10 centimeters will represent how many centimeters on the ground? Right? So every 10 centimeters will represent 40,000 centimeters in the ground, and that will come equivalent to 400 meters. And if we have to report the answer in kilometers, it will be 0.4 kilometer. So the distance AB on the ground will be equal to 0.4 kilometers, right? I'll explain it again. The question was, the scale of a map is represented by a representative fraction of 1 is to 4000. The distance between 2 points A and B in the map is 10 centimeters. The distance AB on the ground will be, as we have been given representative fraction, which is 1 is to 4000. That means scale is 1 centimeter is equal to 4000 centimeters. That means every centimeter on the map will represent 4000 centimeters on the ground. So 10 centimeters will represent 40,000 centimeters on the ground. That will come equivalent to 0.4 kilometers. So the distance AB on the ground is 0.4 kilometers. Let's move on and do the next question. Question is, question number 3. Question is, the plan of an area has shrunk. Why do plants shrunk? Due to variation in atmospheric temperatures and humidity. The plan of an area has shrunk such that a line originally how much? 10 centimeters now measures 9.5 centimeters, right? If the original scale of the plan, was 1 centimeter is equivalent to 10 meters, that is the representative fraction will come out to 1 is to 1000, right? Determine we have to determine shrinkage factor, shrunk scale, we have to determine shrinkage factor, shrunk scale, correct distance corresponding to major distance of 98 meters, and we have to also determine correct area corresponding to the measured area of the measured area of 10,000 square meters, right? So we have to determine these things. So let me read it out for you once again. The plan of an area has shrunk such that a line originally 10 centimeters now measures 9.5 centimeters. If the original scale of the plan was 1 centimeter is equal to 10 meters, determine shrinkage factor, shrunk scale, correct distance corresponding to this, and correct area corresponding to the measured area of this, right? So let's proceed one by one. First, we'll find the shrinkage factor or the shrinkage ratio. Shrinkage factor or shrinkage ratio is given by shrunk length divided by original length. And how much is the shrunk length in this case? Such that the line originally 10 centimeters now measures 9.5 centimeters. So our shrunk length is 9.5 centimeters and original length is 10 centimeters. So the shrinkage factor will come equivalent to 0.95. It's always less than unity, which must be noted. Our shrinkage factor or the shrinkage ratio is 0.95. That completes this. Now we have to find the shrunk scale, right? I'll rub it first, or let me keep it as it is. We also know that shrunk RF is equal to original RF multiplied by shrinkage factor, right? Shrunk reduced representative fraction is equal to original representative fraction multiplied by the shrinkage ratio. What is our original representative fraction? This. Shrunk representative fraction will be equal to original representative fraction, which is 1 by 1000 multiplied by the shrinkage factor, which we calculated as 0.95. So it will come equivalent to, after calculations, it will come equivalent to, right? So our shrunk representative fraction is 1 by 1053. What does that mean? That means now our shrunk scale is 1 centimeter corresponds to 10.53 centimeters on the ground. This is our shrunk scale, right? We calculated shrinkage factor first, then we calculated the shrunk representative fraction, and thereby we obtained this shrunk scale. So part 2 of the question is completed as well. Shrunk scale is 1 centimeter is equal to 10.53 meters on the ground. Okay. 1 centimeter is equal to 10.53 meters. This is the shrunk scale. What was the original scale? 1 centimeter is equivalent to 10 meters. Now this is the shrunk scale. Right? This completes part 2. Now we have to move to part 3. We have to calculate the correct distance corresponding to measured distance of 98 meters. Let me rub it down first. Correct distance is equal to measured distance by shrinkage factor. as we know that correct distance is equivalent to measured distance divided by shrinkage factor. What is our measured distance in this case? 98 meters as given in the question. What is our shrinkage factor? It is 0.95 as already calculated. So our correct distance corresponding to a measured distance of 98 meters will come equivalent to 103.16 meters. This is our correct distance corresponding to the measured distance of 98 meters. Now this completes the part C of the question. Now we have to determine correct area corresponding to the measured area of 10,000 square meters. And as we know, correct area is given by measured area divided by square of the shrinkage factor. Right? What is our measured area? It is 10,000. What is our shrinkage factor? 0.95 square of it. And this will come equivalent to so this is our correct area, right? And this completes the part 4 of the question, right? So we calculated shrinkage factor, we calculated shrunk scale, we calculated correct distance and correct area as well. Moving on. Question number 4. Question number 4 is a rectangular plot in plan is 10 centimeters cross 30 centimeters, right? Drawn to a scale of 1 centimeter is equal to 100 meters. If the same plot is redrawn, on a topo sheet, to a scale of 1 centimeter is equivalent to 1 kilometer, what would be its area on a topo sheet? And determine representative fraction in each case. Right? So the question is, a rectangular plot in plan is 10 centimeters cross 30 centimeters, drawn to a scale of 1 centimeter is equal to 100 meters. If the same plot is redrawn on a topo sheet to a scale of 1 centimeter is equivalent to 1 kilometers, What would be its area on a topo sheet and determine representative fraction in each case, right? So we'll first see the representative fraction of original plan. What is the representative fraction of the original plan? It's 1 centimeter is equivalent to 100 meters, which means right, and which will come equivalent to 1 is to or 1 by 10 raised to the power 4. This is the representative fraction of our original plan. Now what is the actual area on this plan? It's 10 centimeters cross 30 centimeters, which comes equivalent to 300 square centimeter, right? Now what will be the actual area in the field? Actually, since we have scale, 1 centimeter is equal to 10,000 centimeters on the ground. So the actual area will in the field will be square of the scale, right? Because we are measuring area, which will come equivalent to this will be the actual area in field, right? Now what we have to do, we have to see what will be the case if it has been redrawn on a topo sheet, right? What is the representative fraction of a topo sheet? 1 centimeter is 1 kilometer. Let me rub it first. What is RF of topo sheet? It is 1 centimeter is equivalent to 1 kilometers, which is right. So this is the RF of topo sheet. Right. This is the representative fraction of the topo sheet. Now we have to see what would be its area on a topo sheet of this rectangular plot, which has been redrawn on a topo sheet with different representative fraction. And now in the new representative fraction is 1 centimeter is equal to 1 kilometer. So its area on the topo sheet map will be area on the ground, which will calculated, which was equal to 3 into 10 raised power 10 square centimeters. Now what is our representative fraction for topo sheet? Square of it, right? This and this will go 3 centimeters square. This will be the area of this rectangular plot if it has been redrawn on a topo sheet to a scale of 1 centimeter is equal to 1 kilometer, right? So this was question number 4. Let's move on to question number 5. Question number 5 is determine the scale of the plan. Determine the scale of the plan and the representative fraction in following cases. Case number 1, we have to determine the scale and the representative fraction in the following cases, and the case number 1 is a line under 50 meters long is represented by 7.5 centimeters on the plan. Second case is a ground area of is represented by 4.5 square centimeters on the plan. Right? So we have to determine the scale and the representative fraction in the following cases. The case number 1 is a line 150 meters long is represented by 7.5 centimeters on the plan, and the case number 2 is a ground area of 112.5 square meters is represented by 4.5 centimeters square on the plan. Case number 1, we'll take this case. What is the scale of the plan? We have to determine scale. We have to determine RFS, where in each of the cases. Okay, so case number 1. What is the scale of the plan? Scale of the plan is this will come equivalent to 20. That means 1 centimeter represents 20 meters on the ground. This is the scale. And what will be the corresponding representative fraction? Right? So the representative fraction will be this completes a case number 1. We found the scale as well as the representative fraction. It was 150 meters long on the ground, and on a plan it was presented by 7.5 centimeters. The scale came out to 1 centimeter presents 20 meters on the ground, and the corresponding representative fraction is 1:20,000 or 1/20,000. Now case number 2 is that we have to see the scale and the representative fraction in this case, in which a ground area of 112.5 square centimeter is represented by 4.5 centimeters on the plan. Let me rub it first. The scale of the plan is the square root of as length of a ground area of 112.5 square meters is represented by 4.5 square centimeters on the plan. So the scale of the plan by calculation will come equivalent to, which is 5. That means every centimeter on the plan represents 5 meters on the ground. This is the scale, and the corresponding representative fraction will be or 1 by 500. Right? So we calculated the scale of the plan as well as the representative fraction, and this completes our case A as well as case B. Moving on to question number 6. Question number 6 is, the distance between 2 points A and B was found to be 100 meters when measured with a scale of representative fraction 1 by 1000. The distance between same points when measured with the scale of representative fraction 1 by 500 will be. Right? So the question is, the distance between 2 points A and B was found to be 100 meters when measured with a scale of representative fraction 1 by 1000. The distance between same points when measured with a scale of representative fraction 1 by 500 will be. If you may recall the discussions as held in the theory part of the lectures, correct length is given by representative fraction of wrong scale divided by representative fraction of correct scale multiplied by measured length. Right? So the representative fraction of wrong scale in this case is this one. This will be the right scale, and the measured length is 100 meters. We have to find the correct distance between the same points. Correct distance or correct length. So correct distance will be equal to representative fraction of the wrong scale divided by representative fraction of the correct scale multiplied by measured distance, which in this case the distance between 2 points A and B was found to be 100 meters. So the correct distance will come equivalent to this will be equivalent to 50 meters. Right? So this was the question. Right? Distance came equivalent to 50 meters. The distance between 2 points was found to be 100 meters, but it was measured with a wrong scale, with the wrong representative fraction of 1 by 1000, and we had to measure it correctly with a new representative fraction 1 by 500. And as we know that the correct distance or correct length is equal to representative fraction of the wrong scale divided by representative fraction of the correct scale multiplied by measured distance. And in this case, the wrong scale was this, right is this. So we divided these multiplied by the measured distance, which was 100 meters. So the correct distance between points A and B came equivalent to 50 meters, right? Let's move on to question number 7. Question number 7. Question number 7. So the question number 7 is the area of a plan of an old survey plotted to a scale of 10 meters to 1 centimeter measures now as 100.2 square centimeters as found by the planimeter. The plan is found to have shrunk. The plan is found to have shrunk so that a line originally ten centimeters long now measures 9.7 centimeters only. Find the shrunk scale and the true area of the survey. Find the shrunk scale and the true area of the survey. Right? So let's solve the question. The question is the area of the plan of an old survey plotted to a scale of 10 meters to 1 centimeters measures now as 100.2 square centimeters as found by the planimeter. The plan is found to have shrunk so that a line originally 10 centimeters long now measures 9.7 centimeters only. Find the shrunk scale and the true area of the survey. Right? So first we'll find the shrinkage ratio or the shrinkage factor, which is given by shrunk length divided by the original length. Our shrunk length is 9.7 centimeters. Our original length is 10 centimeters. So the shrinkage factor or the shrinkage ratio will be equivalent to 0.97. Right? Now we have to find the shrunk scale. For finding shrunk scale, we will find the shrunk RF first. Shrunk representative fraction is equal to original representative fraction multiplied by the shrinkage factor. What is our original representative fraction? This. Our original representative fraction is, let me write it first. Original RF is, or original scale is, what is our original scale? Our original scale is 1 centimeter is equivalent to 10 meters, which is 1 centimeter is equal to 1000 centimeters on the ground. So our original RF is 1 by 1000, right? Our original RF is 1 by 1000. So our shrunk RF will be original RF multiplied by shrinkage factor or the shrinkage ratio, which is 0.97, which will come equivalent to, after calculations, it will be right. What does that mean? That means that our shrunk scale now is, this is our shrunk RF. Our shrunk scale is that every 1 centimeter will represent 10.31 meters on the ground. Please note this, that our shrunk scale is 1 centimeter is equal to 10.31 meters on the ground. This completes part A of the question. Find the shrunk scale. Now we have to find the true area of the survey. Let me rub it first. As we know, correct area is given by measured area divided by square of the shrinkage factor, right? What is our measured area on the plan? As they have measured it by a planimeter, it is 100.2 square centimeters. What is our shrinkage factor which we calculated? It is 0.97. Square of it, and this correct area will come equivalent to 106.5 square centimeters. So our correct area is 106.5 square centimeter. But this is not our question. The question asks us to determine the true area of the survey. That means, what is the corresponding area on the ground, right? True area of this survey. And as we know the scale, what is scale? Original scale. It is, as we already calculated, 1 centimeter, or as given, 1 centimeter is equal to 10 meters. This is our original scale. So our true area of the survey will come equivalent to, true area of the survey is equivalent to how much? This. Multiplied by, what is our scale? 1 centimeter represents 10 meters square of it, right? Which will come equivalent to 10650 square meters. So this is the true area of the survey, right? This is the true area of the survey. So we completed the question. We found the shrunk scale and we found the true area of the survey as well, right? Let's move on to question number 8.